Hello, everyone. I would like to thank you for joining us today and welcome you at the Luxoft webinar with our expert, Sergii Trotskyi. Sergii is a .NET Latin backend engineer working for the last 7 years in investment banking. And today he will take you through the new features of C#7+, internal structure and implementation. The presentation will last around 45 minutes, and after that, you will have 10 minutes for Q&A section. Feel free to post a question in the QA section at the bottom of your screen. If there won't be enough time to answer all of them, our speaker will come back to you with an email. Also, if you would like to join a great networking meetup and meet Sergii in person, I would like to invite you for our event Logic Night in Wrocław on the 28th of June. I also recommend you to check our Luxoft corporate YouTube channel, where you can find other webinars covering interesting topics. Now I will pass the word to Sergii, and good luck with the presentation.
Thank you very much, Justina. Let me share my screen. Let me share my presentation firstly. First of all, I would like to tell thank you very much that you decided to attend this webinar. My name is Sergii Trotskyi. I have been working for Luxoft Poland since 2014. Before I was working for the Ukrainian division of the Luxoft Global. Today, I would like to speak a bit about the new features that were introduced in C#7+. And the 7+, I mean 7.1, 7.2, and 7.0. Regarding the prerequisites, so in order to make this presentation, I used the latest Visual Studio with the latest update and different disassemblers, just to check how that or that feature was implemented and how the compilers work. So let's start. I do not have any order, like chronological order or alphabetics. So of course, if one feature has a dependency on another one, so firstly I will show the second, and later I will move on to the first one. Let's start from the local function. So to make it simple, local function is the function inside the function. Because of that, we have some restrictions. Yeah. So the restrictions are, it can be called only for the method from the functions that contain it. However, it has access to all variables, instance variables, static variables, and the parameter of the function which defines this local function. Attributes cannot be applied, and it could be declared everywhere, like finalizer, constructor, getter, setter, or maybe Lambda expression, anonymous function, and so on. Now, on this slide, you see the example of the local function. Yeah, so we have some get text static method, and inside that method, we declare a local function which is called append pass separate. Let's speak about the more theory. Yeah, so following modifiers could be applied, like async and unsafe. No static keyword could be applied because it makes no sense. No member access modifier because of the same reason. In case if you have some function with the same name, local function will hide it. The benefit of local function is the allocation free. Of course, if you have no conversion to the delegate. Motivation, why Microsoft team decided to introduce it. So actually several reasons. One reason, for example, imagine that you have big body of the methods. General approach, you just decouple it. Decouple into several parts. Each part you move to separate methods. But these all new created methods will be used only once. And that could confuse another developers which are working with you together in your team, as example. So that's why we received this possibility to declare the function inside, for example, some particular function. And another motivation, which is more important, I believe, is related to the iterated method. Okay. You probably know that for method iterators, exceptions are surfaced only when the return sequence is enumerated, but not when the enumerator is received. So we have methods iterated like this, which are called odd sequence. And we have some code that call this method. So on the first line, we will receive the enumerator and it will be okay. But later, when we already receive the enumerator and we will start to enumerate through the sequence, we will got this exception. Because I put 110, so that's why it should be throw the argument out of range exception. But the local function could change this behavior, and now I'm going to show you how. In case if we will move this enumerated code to the separated local function, compiler will create the state object machine only for this local function. And it means that odd sequence, it will be treated as a normal method. And it means in the line when we will try to receive the enumerator, it's the line number 1, so the exception will be thrown. I believe that this is it's better. Let's move on. Let's compare Lambda function and let's compare the local function. So here you see two functions, the same behavior, the same functionality, but we are using Lambda statement in first function, and we are using a local function in the second one. What will be the difference? In case if we are using Lambda expression, so two objects need to be allocated on the heap. First object will be actually our delegate, so it will be our action. The second object should be allocated on the heap. This is the special holder which holds the whole context. The whole context which holds every variable that currently accessible when we declare our Lambda. If we're speaking about the local functions, so no allocation on the heap is needed, because compiler will transform our local function in normal private function of the same object. Let's move on to another feature that was introduced in, I believe, C# 7.0 is a discards. So discard, this is a contextual keyword. What does mean contextual? It means that it is not the reserved word in the C#, but for some particular cases it could be treated separately. So when we should use discards, for example, if we want to ignore some values which we return from some methods, that we could declare out arguments, or it's another new feature that were introduced in the latest C#, the value tuple deconstruction. For example, if we have the method that returns the value tuple, we have some number of the elements. And in case if we would like to ignore that or that or that element, we could use discards. Logically, discards are some variables, but which are write only. So it means that you could have them only on the left side of the assignment, but not on the right side. I will show you later. It has no name, and discards are represented by underscore. So scenarios where discards are useful: deconstruction of the tuples, or user-defined types. Discards also could be useful when we have some methods without parameters, with like try pairs or something like that. And another new feature that was introduced, pattern matching. Discards could be used there as well. So example of the discards. You see static void main, you see try parse methods, and this underscore is treated by compiler as a discard. It means that it does not care about actual value of the parsing. Yeah, for example, if we need just to check if this or this string could be parsed, so we could use this construction with a discard. If we are speaking about the compilation, and if, we will using disassembler to check how compiler works, we will see that a normal variable will be declared on the stack, but this is the work of the compiler to throw an exception in case it will try to make the statement where the discard will be on the right side. Yeah. So on the screenshot you see that discard could not be on the right side of the statement, because this is only a write-only variable. Underscore could be treated as a variable. So you could declare something like var underscore equals to something. And if you would do that, so in that scope, underscore will be the variable. Tuples. So imagine a situation when we need to return a lot of number of elements from the method. So we have several choices how we could do it. Yeah, several approaches. One approach is to custom build transfer type. It means that we create our struct or we create our class with elements. Another approach is we have one method with different arguments which are marked as without modifier. Third approach is to use the dynamic type, but dynamic type has some performance overhead and there is no stick type checking. And we could choose normal reference tuple object. What is wrong with tuples? So first of all, this is a reference. So allocation of the heap is needed. So yeah, so we had some overhead. We have 8 properties, which is called item 1, item 2, item 3, item 8. And it makes sometimes no sense for us because we could not know that, for example, that using the item 2 we want to retrieve something like this object or this object. Yeah, for sure when we're creating this, when we're developing it, so we know, but later we could forget simply. And the maximum number of properties is 8 as well. So in case if you need to hold somehow I don't know 70 example elements, you need to the latest property assign a new tuple. Tuple literals. So they were introduced in new session. It has new syntax. It has new syntax for deconstruction. No need to make sure that return accessing elements are in the right order. So if we would use the reference tuple, so the code looks like that. But C#, latest C# gives us the ability to write such code. If we would try to decompile this block of code, we will see that compiler transform Z into Z. So compiler transform your new syntax into the value tuple object. It's not the object, but it is the value. So because it is a struct. Inferred tuple element names. So in case if we would like to construct the tuple and we are doing it uses already created variables, there is no need to use this syntax, yeah, because this is redundant. We could use simply syntax on the bottom. So, and in this case, the name to the elements will be assigned using the names of the variables. It's more compact syntax. Deconstruction. So we have our example. In order to deconstruct that, we just need to use such statements. Such statements will be transformed into Z1 using the compiler. In case if it does not care about a particular element returned from the tuple, we could use the discard, which we spoke a bit earlier. So discard means that we will just ignore the first element or the second element. And it is very easy to cast from the value tuple struct to the reference tuple object, and vice versa, because they have these transformation methods. Any type, any, in .NET could be deconstructed. In order the type to be deconstructed, you need to define a method which is called deconstruct. Yes, it needs to be implemented. There is no interface. And in that method, you need to set the out arguments for each of the properties which you would like to extract back to the caller. This is the example. It's very easy. Let's have a look what we have inside the value tuple struct. So first of all, this is a struct. It has 8 properties, still 8 properties, and it implements the equitable interface. It means that if we would like to compare two structs, 2 value tuples, if we would like to check if they are equals, it will be equal if the pairwise elements are equal. Another thing what is very good that in case if you have more than 8 elements, you don't need to manually create this structure of object and nested object, because it will be done automatically by the compiler. So compiler will automatically transform this syntax into this statement. It's much more compact, you see it. Why I would like to recommend to use it? It definitely simplifies the code. We have some kind of flexibility to access all tuple elements because we have the discards, so we could access several of them and not to access, for example, this. It is not a reference type, it is a value type. So it means that you have no overhead related to the allocation the object on the heap. Let's move on to another feature. ref returns. What is ref returns? Actually, this is a statement that returns a reference to a value type variable. Back to the column. Syntax is easy. When we declare the method which will ref return, we need before the type of before the return type put the ref, and after the return keyword we need to put the ref as well. A restriction which we have when we could not use it. When we are trying to return a reference to a local variable which were declared in the method, it's logically because you know that lifetime of the value, I don't know, of the objects that were declared inside the method ends with the closing curve bracket. So it means that for the caller, it will not exist. It cannot be literal null. It cannot be the constant, enumeration member, or async method. What it could be? We could return the reference to the instance field of the object. We could return the reference to the static value field and to the argument passed to the methods. I check some performance, I did some tests, and I see that if we are using ref returns, it has better performance around 37 average, 37%. Let's move on to a new feature which is called pattern matching. There are two types of statements that could be used for pattern matching: is expression, is statement, and switch statement. Let's have a look first into the is expression. So it has three types of matching: the type matching, the primitive matching, and the var matching. Type matching. In case if how to use it? In case you would like to check if the object could be casted to a particular type, we could use type matching with is expression. Syntax is here. In each if statement or else if statement, we could provide the alias which could be used in the block after the if else if statements. It's important to know that variable introduced in the first if statement here is lifted to the outer scope. It means that in case if you try to declare in the same scope some variable with the same name, the compiler will fail to compile it. You could not provide the same alias for if else if statements. So you could not. Why not? Because if you will have a look into the compile code, you will see how it works. So is pattern matching is it is only a synthetic sugar. Yeah, it's not something related to the CLR. So it is only the synthetic sugar, and it transforms this code into that one. So and it uses well-known as keyword. So in case if object could be cast to the particular type, S returns that object. In case of not case, S returns null. You see that. Primitive matching. For sure, we could use equals operator, and we should use equals operator here. Why? Because in case if we use primitive matching, compiler transform that code is count is null into something like if object equals 1, count. It means that this operation requires two boxing operation. And you see that this is just the performance overhead, what we don't need. So don't use it. Var matching. It's something like catch the general exception. So you should not put the statement if, for example, the object is var at the beginning of your construction, yeah, because the pattern will match any value even if the value is null. And the compiler shows that actually, if we have something like is object is var, it will return if true. Switch statement. So this is another type of statements related to the pattern matching. It is just like catch clauses. The first one that matches gets picked. So you understand that order of case clauses matters. Compiler generates code similar to is expression. So you see the switch statement, you see the syntax. We can switch on any type. And the compiler, based on the construction, produces that. Later you will have this presentation, so don't worry. Additionally, we could use when clauses with switch statement. Syntax you could see on the left side. The compile code you could see on the right side. The same basis. So it has and the basis, I mean, it is used as keyword to try to cast, yeah. But you see the structure is more complex. It is used go to, label, and so on. Let's move on. Inline out parameter declaration. So if you have some method and several of the arguments are marked as out, you do not need to declare separately the arguments. You do not need to initialize separately the arguments. You could do it in the same line where you have this method signature. Out parameter has scope in the method where it calls. And the called method is required to assign a value to out parameter before the method returns. If you would not assign the value, compiler will throw an error. Async methods don't have out parameters, and iterator methods don't have out parameters because of its nature. Yeah, because when the compiler sees, for example, the iterator method, it means that the compiler will create the state object meshing. So that's why it's prohibited. This is an example. So you see that we are using inline out parameter declaration here, and compiler just lift it before the method call. It will done automatically. This is a synthetic sugar as well. Binary literals were introduced. So at the moment, we already could create some variables that represent binary, not binary object, but binaries itself. And to help us read it later, the digit separator underscore was introduced as well. It does not matter for the compiler, so we could use it just for the readability. And the digit separator underscore is not limited to binaries literals. It could be used with any other literal like decimal, int, and so on. So you probably know which access modifiers we had till the C#7. I'm sorry. we had public, internal, protected, and private. You probably know what's the difference between them. Starting with C#7, we got new access modifier, which is called private protected. Private protected means that only derived types within the current assembly. So let's have a very quick quiz. Which of the proposed diagrams is actually private protected? I don't know if you have already the possibility to vote, to send it. Okay, I see you could. Okay, you could. Okay. Yes. 6? Maybe not. Who else? No, Google is cheating. Yes. So the correct answer is 2. So this diagram represents the private protected access modifier. Yes. Let's move on. Expression body members. So first time expression body member was introduced, I believe, in C#6. What is the expression body members? It's some combination of standard syntax when you declare the method signature, but when you declare the body of the method, you use some kind of Lambda syntax. But it's not Lambda. By compiler, it will be created into normal function, to normal properties, and so on. Expression body members cannot be abstract member, because it should have the body. Block statements are not allowed. The idea of expression body member is to have one line of body, so one line only, single line statement. Where it could be applied right now: constructors, finalizers, and property getters. So before it was only, we were able only to declare in such way only methods. But now they extend the number of members which we could declare as expression body members. Okay, let's move on. Motivation. Why this feature was introduced? Just to help you to create more readable code. And more, I would say, more maintainable and understandable. On the slide, you could see the example, how it looks like, and how the compiler transform expression body member. So we have some datetime type, and the name of the property created time. On the intermediate language, it will be created a standard property instance. Sorry. Another example. We are using this Lambda syntax to create, to declare and getter and the setter. And you see that there is no difference in comparison with standard property syntax. More examples there. We could define in one line, we could override methods, we could declare properties, so we could declare operators and so Let's move to another topic, which is called reference semantic with the value types. So there are three possibilities. Not three possibilities. There are two possibilities how we could make three. I'm sorry. So three possibilities how we could make our structs read only. If modifier, ref read only, and read only struct declaration. So what does mean if modifier? It is applied to the argument inside the method signature. In case if in modifier is applied and we pass the struct, it means that to the argument it could not be assigned a new struct. We could not directly change the properties of it. Even more, if there is, for example, another method with the ref and out modifiers, we could not pass this argument which was passed to this method within modifier. We could not pass to that method with ref and out modifiers. In case if we pass the class and we have the in modifier, we will not be able to assign it to a new object, but we will be able to change the properties. What is the ref read only? So if we are speaking about the reference to a struct, we could create two types of such reference: general one and read-only one. Read-only one have the same rules as in modifier. In case the reference will be marked as read-only, it means that it could not pass to the struct. We could not pass later this reference to the struct where we have the out and ref as an argument. We could not assign new struct, and we could not change the value of the properties. Let's have a look into that example. So firstly, we define a struct point 3D. It has the state x, y, z, and it has three methods which increment each of the fields. We declare this value here. After this, we create read-only ref to that value. In case if we will try, so we already know that we could not change the properties. But what will happen if we have some methods, internal methods in the struct which change the state of the object? We have the method inc, which just increments the x value. At the moment, the value of x is 2, value of y is 2, and value of z is 2 as well. Using the ref read only origin immutable reference, we call increment some methods which should increment the state of each property. And what will happen when we will try just to write the current state of the properties? What will be the correct answer? So will we have 2 or should we have 3? The correct answer is 2. Why it's happening? Because when we create read-only reference, automatically will be created, let's say, a shadow copy. And such incrementation, some such state changing will be applied to the copy. but not to the object itself. However, let's think, is there any way how we could change the read-only ref? So read-only ref is only a reference to a struct. For sure, if we have, for example, another reference that is not read-only, and it is pointed to the same struct, it is pointed to the same value, and in case if we invoke any method, any member that change the state, so original state will be changed. It means that the read-only reference will show you that changes. In case if we would like to create really immutable object, we need, I believe, we need to combine these two approaches. So first of all, we need to create read-only struct. Yeah, read-only struct is another feature that was introduced. When you mark struct as read-only, compiler makes sure that you should define your properties as read-only, and you should define your fields as read-only. Also, this should be read-only as well, and all members, all fields should be initialized in the constructor. Yeah, all fields should be initialized as a constructor. Let's move on to the default literal expressions. So we have the keyword default of TU, I believe, for years. But it was enhancement, some enhancements. So we need to define the type in the brackets now, right now. So you could use this syntax right now. In general, about the default keyword. The default keyword will return null in case if you have the object, the reference object. And in case if you have the value type, an instance of type constructed with a parameterless constructor will be invoked to assign some value. Right now we could check some different cases on how we could use this default keyword. So we could use default keyword in the if statement. Another option, it could be used in the return statement. Yeah, or we could pass the default to the methods, and in this case, the default value will be assigned and passed. So conclusion. Default literals avoids redundant typing, where the default value is known to the compiler. Yeah, for reference type, it will be null. For value type, it will be parameterless constructor. This is a syntactic improvement, and it has no changes to the CLR. The new code is 100% compatible with the code built by early version of the station compiler. Okay, so really thank you for the attention, and now you could ask me the questions if you have any to clarify something. So you're welcome. Sometimes so the question came from the Dmitry. Why do we need to read only structs at all? Because sometimes we need really mutable objects which will not be changed during the runtime. Sometimes it is necessary for us to have it. Yeah. By the way, if we will have a look into the F#, every object is immutable there. Any other questions? Yes. C# 7.2 is ready to go, and when you will download the latest Visual Studio, you will have a special property which you could use to define which C# language to use, 7.1, 7.2, or 7.0. Yeah, thank you as well. Yeah, thank you that you attended the webinar, Haluk. Yeah. Do you have any other questions? Okay, looks like not. So in case if you, yeah, thank you as well. Yeah, thank you, Dmitry, as well. Okay, so in case if you have some questions, in case if you would like to contact me, you could use my my private email. You could use my corporate email, and the link to my LinkedIn will be sent to you together with the presentation. So let me show you my last slide. Thank you very much. Thank you all. Have a nice day as well.